Welcome back to math. Here are the practice problems for section 6, solving equations. We'll solve each one and then check our work. So here we have 15 equals x plus 5. That means that our variable x is having 5 added to it. We want to get x all by itself on one side of the equation, so we'll undo what's happening. Instead of adding 5, we'll do the opposite. We'll subtract 5. That means that on this side, x plus 5 minus 5 leaves us with just x. And over here on the left, we have 15 minus 5. That's 10. All right, to solve our work, we will write the problem over again. And every time we see an x, we'll write what our answer was, 10. And yes, 10 plus 5 equals 15. 15 equals 15, that's true, and so our answer is correct. Here's our second problem, and in this one, x is both being multiplied by 5 and then 7 is subtracted from it, and that equals 18. So let's undo this subtraction first. The opposite of subtraction is addition, so we will add 7 to both sides of the equation. We always do the same thing to both sides of the equation. That leaves us with 5x on this side and 25 on this side. Now x is being multiplied by 5. That's 5x. So instead of multiplying by 5, we're going to divide both sides by 5. And we'll get x over here, x times 5 divided by 5 leaves us with x. 25 divided by 5 is 5. So if we repeat the problem here, and every time I see an x, I'm going to write 5. Let's see if we get something true. 5 times 5 is 25. 25 minus 7 is 18. 18 equals 18, that's true. So the answer is right. In problem 3, we've got x being both multiplied by 3 and then that whole thing divided by 2, plus 4 equals 10. So let's start undoing the things that are happening to x so that we can get x all by itself on that side of the equation. We'll start by subtracting 4 from both sides, and so we're going to have 3x divided by 2 on that side, and that equals 6. Now 3x is being divided by 2, so let's multiply by 2. I'm going to write it this way this time. So both sides are being multiplied by 2. I have to do the same thing to both sides. That cancels this out, and that's 3x equals 12. Now with x being multiplied by 3, I'm going to do the opposite, which is divide by 3. Divide by 3. I'm left with x equals 4. All right, let's see if this holds up with our test. I've rewritten the problem. Now every time I have an x, I'm going to write 4. 3 times 4 is 12, and I can go ahead and do this in one step. 12 divided by 2 is 6. 6 plus 4 is 10, and 10 equals 10, that's true, so the answer must be right. Here's problem number 4, and this time our variable is a y, but it really doesn't matter what the variable is. Also, we've got 7y plus 8y. Those are like terms because it has the same variable, y, and they're also to the same exponent, so we can combine them. 7y's and 8y's is 15y's. And now y is being multiplied by 15, so we're going to divide by 15. That leaves us with y on this side. 15 divided by 15 is 1. Let's see if that passes the test of checking our work. Every time I see a y, I'm going to write a 1. 7 times 1 is 7. 8 times 1 is 8. And indeed, 7 plus 8 is 15. 15 equals 15. Problem number 5 says 3x plus 8 equals 2. So let's undo the things that are happening to x. Let's undo this addition first, and the opposite of addition is, of course, subtraction. That leaves us with 3x on this side, because adding 8 and then subtracting 8 brings it down to 0. 2 minus 8 is a negative 6. Now we have x being multiplied by 3, so we'll divide by 3. That leaves us with x on this side. 6 divided by 3. Well, 6 divided by 3 is 2, and this is a negative 6. Signs are different, so the answer is negative. All right, let's test that. Every time I see an x, I'm going to write negative 2. 3 times negative 2 is a negative 6. Signs are different, so the answer is negative. Negative 6 plus 8 equals 2, and 2 equals 2. So our answer is right. In problem 6, we have 9x plus 3 on this side and 10x on that side. We need to combine our x terms. So let's subtract the 9x over here. I do that because that lets it completely wipe out. It has the smaller coefficient. 9 is smaller than 10. So it's a good idea to subtract it. You don't have to. You could do the other way. You could subtract 10x from both sides. Both ways work. I'm doing the same thing to both sides of the equation. So 9x minus 9x leaves me with 0 there and 3 here. 10x's minus 9x's is an x. There I am, all solved. X equals 3. Let's double check our work. Every time I had an x here, I've written 3. 9 times 3 is 27. 10 times 3 is, of course, 30. And 30 equals 30. Very good. Finally, problem 7 says 16 plus 4x equals 6x plus 2. Again, I've got x's on both sides of the equation. I'm going to start by combining my like terms. That's almost always the great way to start. So I'm going to subtract the one with the smaller coefficient. Doesn't really matter if I do it that way or not, but I like that method. That leaves me with 16 on this side. 16 plus 4x minus 4x. So that cancels out. We have 16 here. Now 6x's minus 4x's is 2x's, and we still have the plus 2 going on. So let's subtract the 2. That lets that cancel out on this side. We have 2x left. 2x equals 14. Well, we better divide by 2 because x is being multiplied by 2. So that leaves me with x on this side. 14 divided by 2 is 7. Let's see if this works. 16 plus 4. I see an x, so I'm going to write 7 equals 6 times 7 plus 2. Okay, let's do our multiplication first. 4 times 7 is 28. 6 times 7 is 42. Bringing down the rest of that information. Okay, 16 plus 28. Well, 6 plus 8 is 14. That's 3. That's 44. And 42 plus 2 is 44. Fantastic. 44 equals 44.